Hey team, welcome back to my channel. In this video, we will look at the PolyAlphabetic Substitution Cipher. I will show you how to write your own substitution cipher in less than 30 minutes. Mind you, I will explain everything and keep it very simple to follow. You can do this. Ready? Let us demonstrate this program before you write all the code. Notice I have some buttons, I have an area to do a message, and then here is the output when you encrypt. This same zone is used for our input when we decrypt. Now, you can imagine that you have a bunch of username and passwords sitting on a file on your computer. Now notice this has my email addresses and the passwords. And then I have my bank name, login, and password, and it's just a flat file sitting on my computer. Now, that's kind of dangerous. Now, how about we say, oh, I keep that up in an email. Somebody's hosting that for me, so when I need my email, I go to my favorite email hoster, and then I have my emails and passwords available. So it doesn't matter where I am, I can get those values. Well, that's also a problem. That is why a tool like this is useful. For instance, here I can paste in the content of that file that you just saw, and then I can encrypt that, and then notice the values are encrypted. That means I'm not going to be able to hijack this data and, use it other than myself. And I have to have this app available for that to even work. So that's also another problem. But notice here, if I delete this content and then I say decrypt, notice I get it back. Now there's the problem. That was anybody that has this app could have decrypted this message. So what we can do is we can add a private key here. Now I would add something long. I'm just going to do key right now. But this right here is, type something long so it'd be more difficult for the bad guys. So here I have my same message, and now what's this encryption change? Notice the value changed. Now, if I were to encrypt that, I'm a bad guy and I don't know what I typed there. Notice I just get a bunch of junk. Or I can type in that secret and then I can get back to where I was. Does that make sense? So this is just one use of this app. Being able to encrypt and decrypt and have some kind of security is just pretty awesome to have, especially in today's world. And that's the app, my friends. Let us take a look at the encrypt process. Now, this chart up here is very important to understand, and I have simplified it quite a bit so it wouldn't be so complicated. But here you can see that we have an ASCII table, and notice the letter A is 65. And then all the way down to Z is 90. So notice this does sequential, A 65, B 66, and so forth. Now, on this diagram, notice that I started with ASCII 0. That's way over here, 0. And all the way over is to 255. That's this guy right here. So we will use all 256 characters to make up our alphabet to randomize each row. Now, another thing we do is we switch the type. So instead of using 65 decimal, we're switching over to use the hexadecimal. Let's encrypt face. So we have one row that's called our alphabet, and we know that. So we're using the English letters of the alphabet. Now, first we say the letter F. So we go across the alphabet and we say, okay, there you are, F. What row am I on? Oh, I am on row 1. This is my first character. So I come up to row 1, and for F, I would say, oh, I'm going to swap that F with a G. So I would come here and put G. And then let's look at the second letter. The second letter is A. Now notice A, now I'm on my second row. So now it's C. So now I put a C there. My third letter is a C. So I highlight the C. And then I say, okay, what letter am I on third? That's the third row. So that is F. And then my fourth one is an E. So I go find E. And then I say, okay, 1, 2, 3, 4. Okay, that's the I. So when we encrypt face, it turns out to be G, C, F, I. That's how we intake that to that. And that is encryption. Now we're going to talk about taking it from here back to here, and we're calling that to decrypt. So here's my input now. So I'm going to come out and I'm going to say, okay, G, C, F, I. What are we starting with here? Okay, that would be R1, right? And this will be R2, and this will be R3, and this will be R4. Okay, so let's go to R1, row 1, and go find the letter G. Okay, G, okay, so that's the F character. Now row 2, go find the letter C. Okay, that's the A. And then on row 3, go find F. So F is right here, so it's C. And then on row 4, go find I. Row 4, the I character. I is E. So we just took GCFI and we took that back to face. And all we do is we loop over our random rows, find the character, and then look at our alphabet at that same index value. Let us open up Visual Studios and create a project, File, New, Project. We're going to be creating C# Windows Desktop, Next. And what is our project called? We'll call it Poly Substitute and hit Next. And we'll use 5.0, Create. Press pause and create these 4 class files. Let us begin our program. When you open up MainWindow.Xaml, this is where we're at. The only change we need to make to the top here is change the title, the height, and the width. Let's add a grid.row definitions. Notice that we have a 40, a 2. I use these 2s for gutters. Notice I put them between all my big fields. So a 40, a 400, a 40, and a 400, separated by 2s. Press pause, get all those in. We only have one column definition. Notice the width 1024. On our first row, notice row 0 for both of those. We have our clear button and our generate key button. Notice that we got our click events. And then notice on the key generator, I have a margin of 880. That pushes it all the way to the right. Let's drop in our TB text box source. This is where you're going to type your message to be encrypted. Accept returns, accepts tab. That's so we can just do general typing like normal. Notice row definition 4, 0, 1, 2, 3, 4. It gets a little complicated, so we're going to add some column definitions so it makes it easier to program. Notice we have 1, 2, 3, 4, 5, 6, 7. We have 7 columns that make up row 4. Let's get all those in. Inside of the grid row 4, we're going to insert our button encrypt and decrypt. Notice that we have our click events. Let's also add a XOR text box. Remember that enter private key, background light green. Let's add that also to grid row 4. Press pause now. Make sure you get all the content from line 36 to 58. At the very bottom, we're going to be adding another text box, but let's wrap it with a scroll viewer. Notice we're using a vertical scroll viewer, because sometimes the encrypted message can get pretty long. Press pause, make sure you get from line 60 to 67. And guess what? That ends all the XAML code for MainWindow.Xaml. Let us begin with MainWindow C#. So notice that we have 90 lines of code. It all begins with 3 using statements. And then we're going to come down to main window and we're going to initialize components, and then TB source text. We just have a basic little statement in here. We're going to be encrypting this in the demo, and that finishes main window. Press pause, make sure you get that. Then we have our buttons, button clear, button generate, button encrypt, button decrypt, and then this is a supporting message that will XOR our message. So we'll begin with the clear. So we have 3 controls I want to clear out: the TB output, the TB source, and the XOR text box. This is where you'll put your private key. So those 3 lines of code for the button clear. Press pause. Now the generate key, notice that it's very simple. We're going to create a class called vocabulary key generator, and I'm going to be calling generate set, and I want 1024 unique lines created from our alphabet of the ASCII characters 0 to 255. Press pause now for button generate key. On button encrypt, notice the first thing we do is we get the XOR text box value and we put that into key. And then we get our source from TB source and we trim that up, both the start and end. And then what we're going to do is we're going to call this message XOR message down at the bottom. It's going to kind of clean that up. And I'm going to apply that key to the source data, and that's going to be message with XOR. Then we're going to call a class object called translate, and I'm going to init the PolyAlphabetic dictionary. I'm going to encrypt that value, and then I'm going to put that output back into the output. So the output of encrypt will go into the input of TB output.text. So it's a very simple function to understand. Press pause, make sure you get in from line 36 to line 50. TB decrypt, I get that same key. Now we're dealing with the output. So output text, let's trim that up. Then I'm going to go to translate. I'm going to init the PolyAlphabetic. I'm going to decrypt it. And then notice now I'm going to use the output of decrypt to be kind of like the original. And then I'm going to say XOR the original with the key, and that's going to get me back to my original message. And then I'm going to apply that on line 64, message with XOR back to TB source. So remember when I did the encrypt, the first thing I did was I XOR'd before I did any of this other stuff. But when we're unwinding it, I'm taking it from encryption back to regular text, notice I do it at the end. It's a very important part of this. Press pause now, make sure you get 52 to 67. And our last method in here is XOR message. So notice I pass in two parameters, a message and the key. Now if that key is null, return the message. If the key length is 0, return the message. Else, let's build a string builder. And then what we're going to do is we're going to loop over this message, just keep looping over it. And then I'm going to take off one character at a time and put that into CH. And notice this is of type integer. Notice on line 79, I cast message sub I as an integer. On line 80, I use the bitwise exclusive OR operator. The imod key length, make sure I only use the boundaries of that key. And then the variable CH is updated. Then I'm going to add this character to SB, that string builder. I'm going to stay inside of this loop applying that XOR. At the very end, I'm going to return the encrypted message. And that is line 69 to 88. Let's make sure we have our two close curlies. And guess what, team? MainWindow.Xaml.CS is all done. Let's now code up vocabulary key generator. Notice that we have three methods. Let's start at the bottom. Private string build random vocabulary key. Notice it takes a list of integers, and I'm going to call that output random numbers. So notice that I have a string builder, and I'm going to say string builder append key.add, and then I'm going to loop over this list, and this is an integer, and notice I'm going to print it out in hexadecimal. And I'm going to keep appending this line for the number of elements that I have in this output random numbers list. And then when it's done, I'm going to add a close quote, a parentheses, and a semicolon, and that ends the line. Let's see what that looks like. As you can see on line 79, I'm saying SB append key.add. See how it says key.add here? And then a quote / quote, escaping that out. And then I'm going to loop over output random array. Well, actually it's a list. And notice every two characters makes up one of our characters. And notice I'm printing it out in hexadecimal. So then all the way over to the end of that line, we end it with a close quote, close parentheses, and a semicolon. That will represent one line in our PolyAlphabetic substitution. We're going to generate 1,024 of these. In the second method of this class, save keys, notice I'm taking a list of strings and I'm calling that poly_key. Now I'm going to do two tests. If poly_key is null, I'm just going to get out of here. If poly_key.count is 0, I'm just going to get out. If I'm good, I'm going to see if that folder exists, and if it does not exist, I'm going to create it. Then I'm going to create a file there called keys.cs, and then I'm going to loop over this list, and I'm going to write out the lines. Now remember when we did build random vocabulary key, it created individual lines. You saw that. And then that is what I'm going to actually write out to this file. When that's done looping over this 1024 times, I'm then going to show you a message that, hey, in the folder called temp keys, there's a file waiting for you. Let's see what that looks like. Notice in the folder local/t, that's our temp folder, I have a file in there called keys.cs. And here is the contents of that file. You remember generating key.add and then some value. Notice at the very bottom, we should have 1024 rows. And this makes up our PolyAlphabetic substitution. All these lines are part of that. So we'll substitute each line. So if your content has 5 characters, it will use this line, this line, this line, this line, and this line, 5 of them. If your document has 500 characters, we're going to use the first 500 lines. If your document has, 1,000, we're all the way down here at the bottom, at 1,000. So each of the lines will represent just one character. Now, when I get down to 1,024 and it's got 1,025 characters, I start it over again. I come all the way up to the top, and guess what? I just keep working my way down again. And that is the PolyAlphabetic substitution data. Let's now write the generate set. Now notice the input here says number of keys. Do you remember when we were with the main window and we had that button called generate key? Remember it said generate set 1024? Well, this is that function. We are now going to generate 1024 rows of data. You just saw that when I did save keys. Now we're going to begin with using random. And notice my seed is going to be milliseconds. Then we're going to create a list of strings and we're going to call that poly_key. Now it's important to mention this now is we have to have these 5 using statements in there for this to work. So for that number of keys, the 1024, I'm going to do a loop here. Notice I start at 0 and I'm less than 1024. Let's declare 2 lists and 1 integer. Notice input set of numbers from 0 to 255. These are all the ASCII codes. And here is my output random numbers. This is what our program is going to use. So this is the input. That is the output, and we have a local variable called index. Here you can see we're just doing a for loop from 0 to less than 256, so from 0 to 255, and I'm going to put that I value into this input set of numbers. So this is our input from 0 to 255. Now notice input set of numbers from 0 to 255, that's a list. So I'm going to say while that input from 0 to 255 count is greater than 0, let's do this. Our first line, I'm saying index equals random next 0 to the count of this list. Now the first time 0 to 255 is actually 256 characters, well, integers. So between 0 and 256, actually the max it can be is 255. It's going to put a random number in here, and that is the index of the number I want, not the value, and you'll see that in just a moment. I'm now going to access this list by an indexer. It's called index. Remember, we randomly picked that, and it will get the value out of this list and assign it to cur_num. Then I'm going to take that cur_num and I'm going to add it to output random numbers. Remember, that's also a list. And I'm just going to stay inside of this loop until there are no more numbers, sequential numbers from 0 to 255. but I'm going to randomly put them into this variable. Now we have the one trick inside of this to work on this count. As you probably guessed, for this to work down to 0, I'm going to have to remove items. So notice, input set of numbers from 0 to 255, I'm going to remove that index. I'm using this indexer to go in there and remove that index. Now, when we create random numbers, imagine my first number was 9. So I'm going to go to that list in array position 9, get that value, and then I'm going to remove that. But when I come back up here, that array index 9 still exists. It exists with something new now. It will exist until count is less than 9. I'm going to have a demo at the very end of this unit that shows you what happens to this array, and it is going to be very, very clear. So now the array is 0. I pop out of this while loop, and now output random numbers is full. I have from 0 to 255 in a row that looks like, well, I'm going to build that. Remember when we did that build random vocabulary key? It built a string for me with the values in there. The output of this function is the actual key, and then I'm going to populate this object here, poly key, with the key that just got created in build random vocabulary key. I now finish my for loop. Poly key now has 1024 lines in it. I'm now going to take that object and I'm going to send it to save keys. Remember when we wrote save keys, it's just going to take that file, write it out, and then show you where it's located. I also showed you what that file looks like. And that pretty much is generate set, the vocabulary key generator. The goal of me using Microsoft Excel to demonstrate this is so you understand when we were building the vocabulary key generator and I was adding things to the input set of numbers 0 to 255, and then I was taking the value and I was putting it into output random numbers. Let's do that. Imagine our first random number was 14. That's totally random. So can you imagine I come down here and I say, okay, here's the index 14. I'm going to take its value and I'm going to go stick it over here. So that's array index 0, 14. And then I'm going to come remove this row from this table, delete. Now notice the values down here are kind of like off now, right? So you can really see it down here. So when I do randomizer, I'm only going to get the index value. And remember, I just deleted 14, but 14 still exists because it's just an array. I just removed an element. So imagine the next number we did was 23. So 23 was my random number, but the value is 24. So I come over here and I say 24, and that is my array index 1. And then I'm going to come back over here to array index 23, and I'm going to delete that. So now you see that 23 is now looking at 25. Now, can you imagine I knock out 11 and I say, okay, now my random number was 11. Now that's the index. So the value was 11. So I say 11 there, and that's a 2. Then I come over here and I say, let's remove that, delete. So now you're seeing like the array index always stays whole. And notice we go from 0 now to 252. So I'm going to try to create a unique number between 0 and 252. And imagine this time it's 33. So 33 is actually 36. So I come over here and I say 36. That's a 3. And that's 33. That's my random number. So I'm going to delete that. I think you're starting to understand what happens. When I find an array index, I take the value and I put it into the output random, and then I remove it from this list. Remember, we started with 255. Now we only have 251 available. So I'm going to work this down until there are no more numbers left in this list. And then this list, how many items will it have in there? That's right, it will have 256 random values. See, look at this, totally random. 14, 24, 11, and 36. That's totally random. And that's the goal of the vocabulary key generator. Let's now code up the poly class. Notice that we have a public constant key rows 1024. We have an array of strings vocabulary set. Notice it's using that key rows. And then we have our cipher text. Notice it's a two-dimensional array of key row 256. Let's start at the bottom here with load PolyAlphabetic keys. Let us start with just a try catch command. If we try it, we're going to return true. If there's an error, we're going to return false. You can see here on line 26, we're going to declare a variable called ASCII keys equals keys, and then we're going to say load those keys. Remember in keys where we have that 1024? That's what we're doing. So load keys, loads keys here. Then we have a little for loop. We're going to loop over that key rows 1024, and we're going to take ASCII key sub I, and we're going to load that into a vocabulary set. If everything's good in here, we return true, and guess what? We are done with load PolyAlphabetic keys. Let us take a look at build PolyAlphabet Cipher. On line 29, I'm saying C length equals vocabulary set sub 0, get the length of it. That is going to take the very first row and figure out how long that's going to be. And then I'm going to set I to 0. And vocabulary set sub 0 actually looks like this pattern right here. Remember, every 2 characters makes up a character. Now the very first character, this AB, that is the value 171. This is the value in hex. And this is what that character looks like. So here I'm going to loop over R. R is my row. Remember, we have 1024 rows of vocabulary sets. They're randomized. Now C is the individual character. Notice that we're doing it plus equal to. That means I'm going to step through this 2 characters at a time. 2 characters represents nibbles. So 1 nibble here, it's called the high bit nibble, and then the low bit nibble. And then what I'm going to do is, you see this pattern here? Well, I'm going to end up putting it into this array, this char array. And that is going to be R, which would be 0, I would be 0, so 0, 0. And then I'm going to get the char variable out of this. So notice that my pattern is of type 16. That is what we call hexadecimal. And then this char is going to make it look like this character. And its value is 171. And then notice this I will increment local, and I just come back up here and I get the next character, and then it'll be on the 2 and the 3. And then I just stay inside of this loop until I've read this whole pattern and I've loaded up the ciphertext. And there you have build PolyAlphabet Cipher. And our first function, init poly, notice I'm going to say load PolyAlphabet. I'm going to go take that file and I'm going to load it up. And then if I was able to load that up, then I'm going to build that PolyAlphabet Cipher, that command that we just did. And I'm going to stay in there till we're done. And then guess what? I'm going to return true if this is success or false if I failed. And that is the poly class. Let's now work on the translate class. The first thing we need to do is inherit the class poly. Make sure this is public. And notice we have 3 using statements. So we are going to do an encrypt and a decrypt. Those are those 2 buttons in the middle of the form. Let's start with encrypt. We're going to begin by declaring 2 variables. We're going to make text of type string builder and index of type integer, and declaring that with 0. String builder comes from system.text. Now we have our for loop, I is 0 to I less than the source. Now this is the message that you want to take from something written we can read into the polyalphabetic characters, the hexadecimal. Now we only have 1024 rows in here, and it's quite possible you give me a document that's got 2000 characters. Well, we need to make sure that we use the modulus so we appropriately use our list. On line 19, I say char ch equals source sub I. And then I say if ch is greater than 255, what does this mean? Well, source sub I actually returns a type char. And char kind of looks like an integer. And it's numeric. And it shows me the character, like the letter A is 65. So if that char is greater than 255, that means you're kind of like using a Unicode. Maybe like a Japanese or Chinese symbol, or maybe even, like another symbol that's greater than 255. Well, this program only works on the ASCII characters. So the ASCII characters are from 0 to 255. Now, if you get this message here, that means you have an invalid character. You have something greater than 255. This program does not support that. We need this message in here so we don't get boo-boos. On line 34, notice that we're using ciphertext on p_index. Now remember, we're incrementing this each time we go around. So it is, when we look at this right here, this will be for the first character. I will find the character in this one, and then I will find the second character in this one, all the way down until we get to 1024. And if you have 1024 characters, then I use this line. Now, if you have 1025 characters, I have to come up here and reuse this one. And that is what this line does. It makes sure that we use the appropriate line. Here, I'm going to assign that character to T, and then I'm going to take the integer value of that T, and see this X2? That's going to be uppercase hexadecimal. And I'm going to print that, and then notice this is sub-0, and then I'm going to put a dash there, and I'm going to assign that in there, and I'm going to append that to our text. Remember, we declared that of type stream builder. Now, if index is 24, then what I'm going to do is I'm going to break, I'm going to give a new line, and then reset index to 0, else I'm going to keep incrementing. So you're going to get 24 characters per line. Now, on your program, you might want to change this to something else, and you own that. That's yours. After we finish the else statement, that is the end of this for. The for began on line 15, and it ends on line 46. So that is that for loop. It's very, very important. The key here is this one line. Then what we do after we finish that, we are going to return that string. Remember, the button on our front screen calls encrypt, and it passes us in the source. And that is the encrypt function. Now let's take a look at the decrypt function. Notice I start off with an array of separators. Notice I'm looking at 10, 13. That's the carriage return line feed. Remember, if we only have 24 items on a line, at the end of that line in the Windows operating system, it will give you a carriage return line feed. This decrypt message, this hex string, that is the entire pattern. Then what we're going to do on line 55 is I'm going to say rows equals that input hex string. I'm going to trim it, and then I'm going to split it, and I'm going to split it based on this separator, the character return line feed. And I'm going to remove empty lines. So this will be an array of those hex strings. We're going to declare row index to be 0, and then we're going to start our loop. R is 0. R is less the number of rows that are, like in this hexadecimal output, the encrypted text, if you will. After we pick up a row, then we're going to start looking at the individual cells. Remember, there could be up to 24. It's two hex characters and then a dash. So notice I'm saying plus equal 3. So I'm going to get those two, that row sub R sub I, and I'm going to just get 2 of the characters I need, and I'm going to put that in char in hex. Then I'm going to convert that back to an integer. Now what we're going to do is we are on a certain line inside of that keys. So what I'm going to do is I'm going to start at the beginning of that line, and I'm going to go to the end, and I'm going to try to find that character. And once I find it, then I'm going to add that. So I just declared another variable here called SB, a string builder, it's of type string builder, and I'm going to append that character. Remember, we went from the hexadecimal back to the character. You remember when I did the face and I went and I encrypted it and then I had to go back? Well, this is the going back method. After I process that first character, I'm going to increment row index by 1 and then come up here and do it again. I'm going to keep doing it until we don't have any more data that needs to be converted, decoded. Then, after I'm done processing all the rows, I'm going to return sb.toString. This is the decrypted message. You're going to be able to read the original message now. And that is translate. I have set 2 breakpoints in the app to encrypt and decrypt. Let's run this program. So I have this message, and what I'm going to do is I'm going to put in a key here. Let's just keep it very simple. We'll just say key. I can type a whole lot more, but I don't want to have to go loop through all that. So we're just going to say key here. Then I'm going to say encrypt. Now notice this is that value that we just typed in there. Remember when we typed in key? And then this is the source. That is that text that was in there. Can you imagine, right? Now what I'm going to do is I'm going to declare a T of type translate. I'm going to init that poly. Let's go take a look at that. Remember that load alphabet and then build that thing. We're just going to loop over this big one and then we're going to step into this one. And then remember getting the length of that? So that line is 512. Well, why 512? Well, what's 512 divided by 2? That's 256. There are 256 characters in the ASCII table. Then what we're going to do is we have 1,024 different vocabulary sets. So, I mean, we're going to take each one of these and process each one of them. And we're going to put that into ciphertext. And what I'm going to do is I'm just going to break here at 48 on that because that's very, very long-winded. I'll tell you what, let's just do 1 so you can see that. Continue. So I'm on the very first one. And now I'm going to come through there and I'm going to get that first pattern. And notice that pattern is AB, just like I told you here. And then what I'm going to do is I'm going to take that pattern, and because that's hexadecimal, I'm going to convert that to a char, and I'm going to put it in this one. Right now, look at that. Everything is null. When I click this, now let's take a look. Notice it's 171 in that like double arrow, like what I have here. So I think you see that. I'm just going to loop over all that data and then build this ciphertext. Let me take that off. Let's continue. And true. Now what we're going to do is we're going to encrypt that message. But notice it says message with XOR. So we went up there and we took the source data. Remember that can you imagine? And we ran it through this XOR. I should have went through that. But we'll do that on the way out down here. But the goal is I went out there and I used exclusive OR for each character based on whatever key you passed in. And now what we're going to do is we're going to encrypt that. So F11 gets us in there, and then we're going to start looping over that. Now source is all of those characters that we translated. Then I'm going to get the line number. Now is that first character? No, that first character is a 40, right? So that's less than 255. So then I'm going to go find that, and I'm going to put that into T. Now notice that came out to 195. So this is called PolyAlphabetic Substitution. I just substituted a 40 for a 195. Now I'm going to append that. Text right now is nothing. Now we have C3 dash. So the integer value of T, 195, I'm going to print that in hex. And that's what this C3 dash is. Now my index is 0. So now I'm just going to increment it by 1. And now I've already got one element on that row. And then I'm going to go get the next one. What is that one? Well, that is 4. Is that less than 255? Sure is. So I'm going to convert it. So that 4 got translated into the second row, and it's a 225. So I think you're starting to see this now. It's kind of easy to follow. Just got to step through this once or twice and you'll get it. So the third one is the 96 character. It looks like maybe that's a single quote or something. But I'm just going to keep building this text. And then at the very end, I'm going to return that on line 48. Let's run this. Now notice the output. That output is a bunch of hexadecimal. In every 24 characters, there's a carriage return line feed in there. And then when we see this on our screen, we'll see that it's broken down into 24 units per line. And there we have, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. So 25 units per line. Not too shabby, yeah? So now this message is what we send through an email to somebody or save this out as a file. Now to get it back to this text right up here, we have to hit decrypt. And let's do that. And notice that we have this key here. So decrypt. Now I'm in there. So the first thing I do is I go get that key. And that key is going to be, that key's value is key. And then we're going to get our output from the TB output file. And notice that's a series of hexadecimal separated by a dash. Right? Then we're going to load up our translate, initiate the poly, and I don't want to step through that again. And then we're going to decrypt. Now decrypt, I'm sending in this character, F11. And I got my separators. Now notice rows right now is null. Now when I do that split command, I'm looking at my separating characters, carriage return line feed, and I'm going to remove empty lines. F10. Now notice I have 5 lines. C3 down to 7-1. You remember seeing that. Then I'm going to loop over those rows. I'm going to loop over the children. Remember doing it 3 characters at a time, but I only need 2 of them. And then we got our first one. It's a 195. And I'm just going to keep doing this until I'm done with that. Now I'm going to return my string. Notice this right here still needs to run through the XOR because we still can't read that. Hit F11. Now we're going to go XOR that. So here's my original key. Notice that came back from the decrypt. And now I'm going to send those together. F11. Now, is that key null? Nope. Is it 0? Nope. Okay, so I got a string builder. Now I'm going to loop over that message. And I have my key. And then I'm going to use that exclusive OR. And I'm going to reset CH and then I'm going to append it to SB. So notice my first one is C. And then we got CA. And then let me just hit a breakpoint at 85, run this, and then look at our message, can you imagine, right? F11. And then I'm going to update my screen, and guess what? We're done. And there you have it, team, the PolyAlphabetic Substitution Cipher. Now, this is just the basics. I'm sure that you can do a lot of more things with this app. Kick it up a notch. And I would be so interested if you share what you've done with it, and that would be pretty awesome. Maybe we can even create a video together about what you've done. That's all I have for this video. I hope you enjoyed it. I'll see you back in my next video. Have a great week.